Thanks for stopping by again, people. We're continuing our lesson in section 5.5, in which we're working with inequalities in the triangle. Now, we just learned the relationship between where the longest side of a triangle is and where the largest angle is, how they're opposite from one another every time, and saw how you can use that to order the side lengths and the angle measures in a triangle. Now what we're going to do is we're going to look at how you find the possible side lengths of a triangle. It turns out you can't just make a triangle with any side length you want. You can't just say, I want a triangle that's 5 centimeters long on one side and 10 centimeters long on another side and 15 centimeters long on a third side. Sometimes random numbers will end up working out, but often they will not. I need you to understand at the end of this video how to determine whether certain side lengths could actually be used to form a triangle. So how do we do that? I'm asking the question here, is it possible to draw a triangle with indicated side lengths? And I'm wanting to draw a triangle that has side lengths of 2, 3, and 8. Now, what I've done is I've gone ahead and drawn the 8 unit segment. You can count there and see that that's 8 units long. And I want to show you that it would be impossible to have a side that's 8 units long and sides that are 2 and 3 units long. Now, I want to use circles to do this. Let me draw a couple. Now, it kind of looks like I'm drawing a bicycle here. That's not necessarily the point. But what I've done is I've drawn one circle that has a radius of 2 units, and I've drawn another circle that has a radius of 3 units. I don't think this one's a perfect circle, but the illustration will still be decent. Notice that if I try to draw a segment that's 2 units long, and a segment that's 3 units long, that's the radius of each circle, right? They're not going to actually be able to connect because the 8 unit side, its vertices are too far away for a 2 unit side and a 3 unit side to actually reach one another. And so why is it that these 3 numbers don't form a triangle? What is it about them that I could have known ahead of time it wouldn't be possible to make a triangle? Well, it's the fact that 2 plus 3 is not greater than 8. Now, I'll try to build on that idea with the next example, because now I've got an example of distances that we can actually make into a triangle. All right, the question is still, is it possible? But I'm telling you, it is possible. I should have said no on the last one, right? It was not possible, and that's because 2 plus 3 is not greater than 8. Now, let's look at this one and see if it's possible. And I'm going to use the same basic strategy. I'm going to make a circle that has a radius of 4. I'm going to make a circle that has a radius of 5. And I'm going to show you how you can use those to actually make a triangle that has units of 4, side lengths of 4, 5, and 8 units. All right, now you can see how this first circle on the left has a radius of 4 units. You can see how the circle on the right has a radius of 5 units. And you can also see that those circles overlap one another. And it's the overlapping part that's really going to matter. Now, turns out I can make a triangle that has a 4 unit side right there and a 5 unit side right there, along with the 8 unit side that I've already created. There's a triangle that has sides of 4, 5, and 8 units. That was possible. Now, I could have made it down here as well. There's a second, whoops, well. Now, there's a second triangle that has side lengths of 4, 5, and 8 units long. It is possible to do that. And the reason is because 4 plus 5 is greater than 8. Now, let me actually put that to you another way. The way you know if it's possible to take 3 numbers like these and make a triangle with those side lengths is if when you add up the 2 shorter distances, is their sum greater than the third? 4 plus 5 adds up to 9, which is greater than 8. Whereas in the previous problem, 2 plus 3 adds up to 5, which is not greater than 8. So add up the 2 shorter distances, see if their sum is greater than the length of the third side. If so, it's possible to make a triangle with those side lengths. All right, well, that's part of what's called the triangle inequality theorem, and I want to explain that to you right now. I'll tell you in words what the actual theorem says, and then I'll use some symbols to show that with this particular picture. The triangle inequality theorem says that the sum of any 2 sides of a triangle is greater than the length of the third side. All right. Now, the way we're going to think of it, generally speaking, is that if you add up the 2 smaller sides, the 2 shorter sides, that the sum of their lengths is greater than the third side. But the triangle inequality theorem literally add any 2 sides together, that sum will be greater than the length of the third side. So here's how that would look for this triangle. For instance, if I took AB and BC and added them together, that would have to be greater than the length AC. Well, I did the wrong thing. I meant to put BC right here. There you go. If you add AB and BC together, their combined lengths are greater than the third side AC. Same with any pair of sides. Let's say we would add up AB with AC. That sum would have to be greater than the length of the third side BC. And then finally, AC plus BC, the sum of those two lengths would have to be greater than the length AB. Fairly easy to use. Add up any two sides. All right. Has to be greater than the length of the third side. I want to use that now to not determine is it possible to make a triangle with certain side lengths. You've already seen how that's done. But this time I want to tell you what two sides of a triangle are. Two sides of a triangle are going to be 11 centimeters and 14 centimeters. And what I'm going to want us to do is describe the possible lengths of the third side. Now I'll draw a picture. It's not necessary to answer this question, but I'll draw a picture nonetheless to help us out. And so I've got an 11 centimeter and a 14 centimeter side, and let's just say that this third side is x centimeters. Now, in order to figure out what the possible values of x are, we don't know it. This could vary in length. We need to just basically use the fact that if you add up any two sides of the triangle, the sum of their lengths has to be greater than the third side. And that will give us a few inequalities that will be helpful. For instance, if I add up x and 11 together, well, that sum has to be greater than 14, doesn't it? I'll come back and solve that inequality here in a moment. If I add up 11 and 14, that sum has to be greater than x. And if I add up x with 14, that sum has to be greater than 11. Now, of those inequalities, one of them is kind of useless to us, and that's this third one, because 14 on its own is greater than 11, so there's no point in us trying to figure out what number you'd add with 14 that would give us something greater than 11. We can't have a negative side length, and so there's no possibilities for what x could be right there. So this is kind of worthless. I'm going to cross it out. But I will solve the other two inequalities. So if x plus 11 is greater than 14, we would get x is greater than 3. That means this third side of the triangle has to be at least 3 centimeters, right? Or has to be greater than 3 centimeters, in fact. Because 3 plus 11 equals 14 is not greater than 14. All right, but 3.1, for instance, would work. 3.01 plus 11 is greater than 14. All right, you can see that that would make a possible triangle. And then if 11 plus 14 is greater than x, that means 25 is greater than x, which we can then kind of reverse and say that means that x has to be less than 25. All right? Now, this is only a sketch right here. This is not the actual figure. It's not drawn to scale necessarily. This doesn't look like the longest side of the triangle, is why I'm saying it, but the unknown side could have been the longest side of the triangle, but it has to be less than 25 because 11 plus 14 has to be greater than whatever this is, and they're not greater than 25. All right, so the possible lengths of the third side, you can describe this way. The third side is between 3 centimeters and 25 centimeters. Pick any number that's not between them, and you'll end up where two sides added together are less than the third side, and that doesn't make a triangle. All right, hopefully you're finding this triangle inequality theorem quite easy to use because it's really not that big a deal. Thanks for watching, guys. As always, I appreciate that. I will see you next time.